Geometric isomerism. This geometric isomerism is peculiar to unsaturated alkene. Alkene are specifically or they undergo geometric isomerism. If you can understand or remember what we learned, alkenes are known by the presence of a double bond. Anyway, it's a double bond, we're talking about alkene. So they exhibit geometric isomerism. One of the reasons is that that double bond hinders free rotation of that carbon atom. Just as you have seen in structural isomerism, those carbon atoms can rearrange themselves, but it is not so in alkene because that double bond hinders free rotation of carbon atoms. So you have cis and trans isomers. You have cis and trans isomers in geometric isomerism. So don't forget that alkene undergo geometric what? Isomerism. Let's take example. I'll put two examples on the board so that we digest it at once. Watch these two examples on the board. So if you watch, how many carbon atoms do we have there? It's four carbon atoms. So we can start numbering from here. One, two, three, and what? Four. The same thing with this one. One, two, three, and four. So if you watch, you have two groups, that methyl group, on one side, as in they are facing up. That one is what we have six isomer. When you have the same subject group in one side or at one side of that carbon atom, we're talking about what we are talking about there is cis. But when they are in opposite direction, you have trans. Don't forget that the prefix for trans, or the simple meaning for trans is across. So now this one we have six. One, two. Okay, let me simplify the way it will be okay. Six boot, two N. And this is a trans boot two N. Also, this one can go six two boot T trans two boot T. I'm giving you options in case you see anyone, they are correct. This one is correct, this one is correct, depending on how they wrote it. So this is 6 boot 2 in. Why 2 here? Because carbon number 2 is the one carrying the functional group. Don't forget, carbon number 2 is the one carrying the functional group. Don't forget what we learned. So 6 is because these two groups are at the same face. Let me put it that way. They are facing the same side. That is why it is 6. But if you watch this one now, they are not facing the same side. One is up, another one is what? Down. That is why we have trans. Do you get it? Trans and the cis isomers. That's what we have in geometric isomerism. That's what we have geometric isomerism. Now let me give you another example. Let me give you another example. I always put it into because we have cis and trans. So this one should be what? 6. 1, 2, dichloro, ethyl. And this one is a trans. 1, 2, dichloro, ethyl. Check it very well. Said because of the fact that two chlorine groups are on the same side, it is six. That is six isomer. And the carbon number one has a chlorine group. Carbon number two has another chlorine group. That is why you have carbon number one, one, two, di. To appreciate the two chlorine group, I put di. Don't forget the prefixes we have learned. If there are three, we put tri and so on and so forth. Dichloroethene. Why ethene? Two carbon atom. This one, why butane? One, two, three, four carbon atoms. The same thing with this. The chlorine groups are now facing they are facing each other. They are now in opposite direction. They are not in the same direction. So that is why we have trans one, two dichloroethane. This is all about trans and the cis isomers. In any which way they put the drawing, or they can as well put the name and ask you to draw. I believe you can do that comfortably. Let's check optical isomerism.